Hey, what's up? Chicago and I back here, and we're going to be doing another video today in our series, Pop, another server drop. In this video series, what I like to do is go through some capture the flag or war game VMs to teach some basic concepts of cybersecurity and also methodology. The idea here is that I go a little bit deeper into depth as far as the details go, as far as what am I running for commands, why am I running them, why am I doing certain switches to the commands, things like that, so that we don't fall into this script kiddie status or anything like that. So the idea is a little bit different than the normal walkthroughs you would see online for things like this. Like if you did a TryHackMe walkthrough for ICE, it may just kind of go down through and just show what the guy was doing, and that's fine. There's nothing wrong with that at all. But for teaching purposes, I prefer to actually detail exactly what I'm doing, and I like to make these videos self-contained. And what I mean by that is you don't have to watch the other previous videos in the series to understand some of the concepts that we're doing here. So you'll notice as you watch through all the different videos, I tend to repeat myself on certain things like Nmap, ports, and things I've explained in other videos, I explain again in the next videos. And like I said, it's the intention to say that, maybe the person is just watching one of my videos in my series, and I don't want to kind of leave them empty-handed as far as the information goes that we have here for. So today we're going to be tackling this one here from TryHackMe called ICE. And TryHackMe, if you're not familiar with it, is a great site where you can go in there and practice on different VMs and rooms. And it's what kind of sets it apart from some other ones is they allow the users to create these things here like this right here, where it goes over some different questions to kind of poke and prod and not necessarily give you the answer, but give you some hints and give you some objectives on actually popping the box and owning the machine. So it's a very cool one, and I actually pay for the monthly subscription, and that allows me to be able to run my own Kali Linux within a browser, which is pretty cool, and also create my own rooms and things like that. Plus, I just like supporting this particular one because I think this is probably the best one out of all the other ones that I've tried. Outside of just plain and simply downloading a VM from VulnHub, this one here is really, really handy. So we're going to be tackling this one today, and it's a Windows box. Well, we'll find out. Windows 7. And we're going to do some privilege escalation. We're going to learn a little bit about Metasploit and Nmap and some other cool things. So let's get popping. So this one here, we do a little recon to start it off. So I started the machine. Here's the IP address of the victim in this case here. So what we do is we run our Nmap command. Now normally I'll have my Dratus machine up, which will have all kinds of different commands. I actually forgot to do that before this video, so I'm not even going to really worry too much about that because I'm not worried about it. We'll just skip it for today. So what I've done here ahead of time, just to save a little time, is I've ran a particular command. It's called Nmap. So again, like I mentioned, I'll repeat this from previous videos. This is scanning for ports. Now, ports on a machine, you have 0 through 65,535 ports. And in that particular case, there's some that are what they call well-known ports. And ports, think of ports as an entry point into a remote machine. So I'm coming from my client machine over to a victim server or laptop or whatever. The port that I go into on that one is kind of my way into the machine. If it's open and I can actually get into it via some exploitation, that's kind of what we're trying to do here. So we want to run Nmap to see if there are any open ports and if they're actually using certain services on them. Now, as I mentioned, the first 0 through 1023 ports are what they call well-known ports, and those would be things that like HTTP, port 80, SSH, port 22. Those are always going to be those ports. Now, when I say always, I mean it recognizes that. So if I type in a browser an IP address of an unencrypted web server, I don't have to type at the end of the IP address :80 because it's a well-known port. I just type in the IP address and it just assumes it's port 80. Now you can host your services on different ports. It doesn't have to be the well-known ones, but the user would have to do a : and then put the actual port number at the end of the address to reach it. So those are going to be called well-known ports. Then you have from 1024 to about 49,000-ish, somewhere up in there. That range is what they would call registered ports, and there's an entity called IANA that kind of maintains all of these, and those would be ones where if I had some software like Citrix or Cisco or something like that, and I said it has to run on this port, then I would register with IANA that port. So now it's known that that port is being used for this particular service. And then from 49,000 on up to 65,535 are what they call dynamic ports. And those would open as you connect to a server. If I'm connecting from my client to a server that's hosted on port 80, I'm going to port 80, but the port that is being opened on my machine to get to that is going to be one up in that range. It's just dynamically created by the machine. All right, so Nmap is a tool that will allow me to scan ports on a machine and see, just by poking and prodding, what's on there. Now, if I just did Nmap with no switches, and what I mean by switches are these little additional parameters right here that you add to a command, and I'll say tac. So if you see me say tac n, that's what I mean by that. But without any of these, it will just scan and see if these ports are open. So it would show that these are open, like that. But this additional detail is not there unless I add some certain switches in. So let me go over the switches we have here. So the TAC-N basically disables the DNS resolution. To me, that speeds up a little bit because I don't have to worry about doing DNS resolution. I'm working on an IP address. I don't really need to know any of that. The TAC capital P-N will skip the pinging for host discovery. And you can see right here, right there, host discovery disabled. So all will be marked as up. So it doesn't do any pinging. The reason I do that is because I've run into some servers where the Nmap scan will fail and not find anything because they have ICMP, the protocol for ping, the software ping. It will disable ICMP on the server side, so it won't allow anything to happen, because one of the initial things Nmap will do is it will do a ping to see if it's alive or up. So I disable that every time unless I specifically need it. The S capital V, and yes, it is case sensitive. The S capital V is for version scan, and what happens is Nmap has a list of different characteristics or attributes of particular software. And if Nmap kind of probes that port and it gets a response back that matches some of those characteristics or signatures, it now has a high degree of confidence that it's this particular software and this particular version. So that's usually what I'll do to try to find out if they're running a particular server version of something, okay? And then the TAC S capital C would be for the default scripts. So Nmap has the ability to has a scripting engine to give it more capability, even as an exploitation tool. And there are some categories they break them into. So there's some that are vuln category. There are some that are intrusive, which will actually, cause maybe a DOS type of situation. And then there's some that are marked as safe, and there's some default ones. So when I run, if I wanted to run like this script right here, or if I wanted to run this script here, I would specifically type those in my Nmap switch. But because I'm wanting to run all the default ones, all the scripts that are in the default category, I just do the S capital C, and it does all of them in that category, including these ones that you see right here. So that's basically what I'm doing, and this, of course, would be the IP address of the victim. So here we see we have some 135 and 139, so we have some those NetBIOS ports there. Then we have this HTTP, and this is what I was talking about. They don't have to be on port 80, right? It is an HTTP web server, so you would think it's on port 80, but it's not. So kind of tricky there, and that's why I'm pointing that out. So we can see they're running a web server on that particular one, which is kind of interesting. And then they have the OS Windows, and then we see some NetBIOS stuff here. Now, what's interesting is that they're not showing the one that this one is actually based on. So I'm kind of curious as to that. So let me ping this and verify it's up and running, because it's actually running another service called Icecast. on port 8000, or supposed to be. So I'm kind of curious of why it did not find that. All right, so it is up. So let me just specifically, just to test here, I'm going to actually just specifically look for port 8000 because I happen to know the name of this room is called ICE. And the reason why is because we're going to be pulling an Icecast server. So I'm going to run that. Oops, I got to put the IP address. That'd be handy, right? So let me grab the IP address. Copy. And okay, so we do see something there. I'm curious why it didn't pick it up originally. So let me do an S-V on it just to verify that it's an Icecast server. Just kind of show you what's going on with that. And I'll also do our TAC-N, TAC-PN as well. And we'll see if it pulls up the Icecast server. Now, it's supposed to be an Icecast server, so I'll let that do its thing for a minute. And as you go down through it here, it's asking those sort of things. It's asking here, hey, you got RDP open, 3389, which is Remote Desktop Protocol. And then it says, what service can be identified running on port 8000? In this case, Icecast. Now, they do give us some additional stuff if you did the hint, right? But in this case, we don't really need that. And like I said, I'm not really sure why it's doing what it's doing. So hopefully that doesn't screw up our exploits, but it is there, and we'll come back and look at that again. All right, so it's saying here that the Icecast server is being used, and then it just gives us a CVE details. So CVE details is where you can go. It's the common vulnerability data source here. And we can type in anything we want to see if there's any known vulnerabilities for this particular software. So if we just type in Icecast, it should give us some different ones here. Let's see. I guess we could go with what is it? Which one is it? Code execution, I think. I think it's code execution, if I'm not mistaken. Code overflow. Let's see. Let's look at the vulnerabilities here. All right, so the one they're looking for, which is kind of interesting here, is execute code overflow. So let me do this. Some weird things happening today. Why it's not actually working properly. Let's just do an Icecast CVE. And let's see if this gives us more. Okay, so that's weird. Things are really weird today. I don't really know what's going on with that. But anyways, we got the ultimately where we want to be. So here we see a variety of different vulnerabilities. Now, we don't actually know the version number. And Nmap, I don't think, even gives us that particular version number. And see right here, if you see port 8000, I don't remember that being in the original. So let's go up here and look and see. Maybe I missed it. Nope, I didn't miss it. So every now and then, this will happen. So I'm glad it did here on screen here so you guys can see that sometimes you may need to run it more than once. Now, something else to keep in mind is without specifying things, Nmap, in this case, the one that I have listed here, the command, it will scan the top 1,000 ports. So it's not actually TCP ports, actually. So it's not actually scanning any UDP ports. And it's not actually scanning all 65,535 ports. If I did want to do that, which sometimes you may have to do in a CTF, you would use the switch TAC-P TAC, just like that, right? And that will go ahead and scan all ports. And if you specify TAC-S capital U, then you're going to actually go ahead and scan UDP ports as well. But that's beyond what we're doing here today. But you can see here, not everything works the first time. And sometimes you'll have to do something like this to get additional information. So here we can see we do have our Icecast media server running on port 8000. And we do see there is some vulnerabilities. Now, they mention in the room that we're looking for a score of 7.5. And if you look at the hints, it's saying here the vulnerability type. And then if you look at this hint, it's telling us specifically that it was disclosed in 2004. Because outside of that, you don't really have any other information about this, but they're giving us some information here. So knowing that information, we come back and we look at the 7.5s that we have here, and we look for one that starts with 2004. So in this case, we can see it's an execute code overflow, buffer overflow. 7.5 is the rating it gives it for CVE, which is pretty nasty, pretty bad. And in this case here, that's the CVE number. Okay, there is a Metasploit number for it. If you actually click on it here, a lot of times it'll give you some information, even a Metasploit module. And it says here, interestingly, there are not any Metasploit modules related to the CVE. Now that's actually 100% false. So I'm not really sure what is going on with this stuff here today, but either way, it's still fun to smack around here. All right, so we're going to actually utilize something called Metasploit. So let's get right on into that bad boy. So Metasploit is a exploitation framework used by a ton of people, not just good guys, but bad guys alike. And it has so much different cool functionality in it. But what's really handy about it is it kind of is a repository of different exploits and different payloads that are known. And usually if an exploit comes out in the wild that's not having to be paid for, it'll usually be picked up by Rapid7 to be put into this particular framework. To run Metasploit, you first have to start a PostgreSQL server or database server to do that. So we do service PostgreSQL start, if I can type correctly, just like that. And it will start the PostgreSQL server database that it actually connects to. Then if this is the first time you've run it, you have to create MSF users in that database. To do that, if you're using the current versions of Kali Linux, you would do MSFDB space init, just like that. Now I've already done it, so it already shows that I've already done it. Next, to get the console, not the GUI, we type in MSF console, all one word, and hit enter. And then we'll go and it will start up and it will give us some cool graphic. And these change often, and they have sometimes weird pictures of cows and aliens and all kinds of weird stuff. So this message will typically be different each time you bring it up, so don't be surprised if you see that. But you can see here we got about 2,000 exploits. We have around auxiliaries, we have about 1135, and those will be things like some scanner tools, things like that. 359 post-exploitation models. So once we've exploited, that's kind of lateral movement or privilege escalation. We have some payloads, quite a few of them actually. And these would be all kinds of different OSs like Linux and Microsoft and things like that. And then we have some encoders and then some NOPs for the, buffer overflows. So in this case here, also some evasion. So what we're going to do here is usually what I'll do is to make sure it's connected to the actual database of PostgreSQL. I'll type in DB_status just to verify, because if you don't have it connected, it's going to be a really, really slow search. It's going to take a while to search for things because it's got to populate it. So in this case, it's connected to it, and we're going to search for that CVE. Okay, so it was 2004-1561. That was the one we were looking at back over here. Okay, so the 2004-1561. You don't have to put in CVE. Typically, you can just do this. So let's do that real quick. And we'll do a search to see if there's anything here. All right, so we see it is an Icecast, so we know we're on the right track. And it's a header overwrite, which tells me it's some sort of buffer overflow. Now, to make sure that you don't fall into script kiddie status, and what I mean by script kiddie is it's a term used in the hacker community for individuals that essentially just kind of go on, I don't know, I'll just pick on YouTube. They'll go on YouTube, see some videos on how to pwn Facebook or what have you, and they'll just kind of like type all the commands that are shown and not really know what's going on. They don't understand the methodology behind it. There's no rhyme or reason to what they're doing. They're just typing commands, copy and paste, and they want to pwn things and they don't really understand what's going on. You don't want to kind of be in that mindset. You always want to know, okay, why am I doing this? What's the methodology behind it? what could actually happen if I'm discovered? Is there a way for me to not be discovered by the victim? Those sort of things. In CTFs, not so much, but in the real world, as a pen tester, you don't want to really be detected. So you have to think of things like evasion, stuff like that. So a lot of times you want to kind of understand what is actually going on with this exploit. Why is this an exploit? So on the modules, what's cool is you can type in the word info, and it will kind of give you an idea about what's going on in this case here. Now, this one's actually not very full of information, but a lot of times they are. So it depends on who actually writes the exploits and puts them into the Metasploit database. Sometimes they're very verbose and tell you exactly what's going on. But essentially what we're doing with the overwrites here would be something called a buffer overflow in this case. But kind of interesting how they don't really have much information here for us, but that's okay. So what we're going to do is we're going to actually use an exploit. To do that, you have to highlight all of this right here, and you type in the word use. Make sure you're at this prompt, MSF6. So you're going to type in use, and then you're going to go ahead and paste in the exploit that you see listed. All right, so now it has here, it says no payload configured. Now what you can do, if you don't want the payload that they have here by default, is you can type in show payloads. And what it will do is it will show you relevant payloads for this exploit. And because this one in particular is a Windows one for Icecast, almost all, I believe it's just Windows, all of these you're going to see are based off of Windows. And these are just different types of payloads that you can get. Some may be just a bind command shell, some are reverse TCP, things like that. But in this particular case, it defaulted to a particular one called Meterpreter, reverse TCP. Now, if I type in the word show options, and you should always do show options, always, you can see that it's actually going to go ahead and ask us for a few things that are required. So under this section here, we can see it says required and then yes. You can see it's blank under our host. Now, do keep in mind, a lot of exploits have the word our host, singular, but this one in particular has one called our host, plural. And so it doesn't, it's doing that to allow you to put a CIDR notation if it's a range of IP addresses that we're trying to exploit for the server. So in this particular one, we know the our host is our victim machine that we're going to put in there. So we're going to set that. But you notice it gave us a payload called Windows Meterpreter Reverse TCP. We didn't set that. It actually just defaulted to that. And the idea is this: if you have a firewall that's stateful, the concept behind a stateful firewall is that it will block everything from the outside coming in that you don't request. So if I didn't request some jabroni trying to send me some sort of, Ryuk ransomware or something, to my machine, to my firewall, it'll hit my firewall first. The firewall will look at its table and say, you know what? I don't know who this player is. This guy's a joker, and we don't want this, and it will discard it. Now, it's different if I'm inside, because if I'm in my network or inside my firewall, it's trusted. It's considered the trusted area. So if I request a web page out on the internet, it's going to go through my firewall. The firewall is going to note it in a table saying, hey, Rayconfer, asked for this particular, web page. And if it comes back from that address it asked from, then we'll let it through because we know it's solicited traffic. It's something that Ray asked for. So a lot of times that's a way to kind of get around being blocked by a firewall as an attacker, because here we're saying that the user, the victim in this case here, is asking me to join them, to connect to them. And that way I can kind of get past that whole firewall business. That's why we would call it a reverse TCP in this case here. Meterpreter is an actual command shell that's really got a lot of functionality to it. It's not your typical command shell. It's got a lot of cool stuff, and it's specific to this Metasploit software, and I'll show you kind of what that is. And so that's something we would want. However, in the real world, do know that most common antiviruses will reject that because it's a well-known signature. Meterpreter is. So it's not as likely you'll get that. If you're using a very decent or common antivirus, it'll probably flag that and quarantine it. But for the purposes of demonstration, this is the way I'm going to show it. Now, again, you can have another option to do a reverse shell instead of Meterpreter, but for this particular one, we'll do Meterpreter so I can teach you that. All right, so let's a few things here. First, we got to set our host. So let's go over here and grab our victim machine in this case. So to do that, you type in the word set and then whatever that value is. Now, this is not case sensitive, so you do not need to have capital letters on that. So I'm going to put my IP address of my remote host. Now, in TryHackMe, we connect via OpenVPN. So you can see right here, I have an OpenVPN connection. Therefore, it's going to give me a tunnel address to reverse connect back to. So if I type in ifconfig, if you're using TryHackMe and OpenVPN, it's actually not going to be this address here. Excuse me. And that's the default that you see here that they're using. So they're using the ETH0 for the L host to connect back to, but that's not going to work. We actually want to connect back to our TUN0, our tunnel one, right here. Okay, so we're going to grab that. And we're going to come back here and we're going to set our L host. All right, there we go. So if we do a show options again, we can see everything's filled out. Now, we don't have to put the port because it's already there. Now, a lot of times, something to remember for the real world is any good security admin worth their salt will be more than likely monitoring for that port because that's the default port for Meterpreter. And it's very common to see that coming into different companies. So if I was a good security-minded admin, I would be filtering for that particular port. If it opened, I would want to know. So you can change it to 443, whatever you want, right? In this case, we're not really worried about it. Up at the top, we can see that the R port 8000 is the Icecast server one that we have listed, and this is the R host for it there, okay? We're not really worried about the target for right now because we're just basically saying whatever's on that machine, we're going to try to hit. So now that we have everything we need, we're going to type in the word exploit, and we're going to see what happens. Send in stage, telling us that we are sending our Meterpreter shell, and pop, 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 another server drop. We now have Meterpreter prompt. And let's take a look here at some of the cool features of Meterpreter. So I'm going to type in the word help, and we'll take a look here. So we can do some different things like timestamp, which is manipulate file attributes like the creation date or modify date to evade the all CNIs of Sauron. Of admins that are looking for that, right? They're looking to see has a file been changed or what's the creation date or what's the modify date. We can change those things with timestamp. This one here will go ahead and tack into LSASS and do a hash dump to get all the credentials of what's on the machine. This one here is some attempts to get privilege escalation. Here you can see you can record someone's laptop microphone. You can do you can grab their stream, which is why sometimes you see people that put tape over their laptop camera so they don't have something like this happen. But as you go up through here, there's all kinds of different things, like you can do a keylogger. I mean, just all kinds of cool stuff. We're going to probably utilize this one, sysinfo, because we want to kind of get information about the victim that we broke into. We can drop into a regular command shell if we wanted to. PS, we'll probably use that one to list running processes. This one here, get UID. We want to find out who we're actually broken in as. What's the user ID? And then here, get privs. We'll probably do that after we do a little privilege escalation to see if we get that as well. And this is a good way here to clear event logs so that they don't, kind of clean it up after yourself. And again, this would be something that a script kiddie wouldn't do. This would be something that a well-informed security professional would do as part of their methodology, right? They have the scan and enumeration portion, they have the gain access, they have the privilege escalation, and at the end, we have the cleanup, right? Because we don't want them to know that we were there. So, it's all method to the madness. So all kinds of different cool stuff we can do with Meterpreter. All right, let's do a sysinfo first. And all right, so it looks like we're on a 64-bit architecture, and it's a Windows 7 and Service Pack 1, and it looks like the computer name is Dark PC. Let's find out who we've broken in as. All right, so we have a guy named Dark, and that's the username. Very cool. And you'll see that in this challenge portion here. It's going to ask you, I think right here, right there. What user is there? What build is the Windows system? What architecture are they using? x64 would be 64-bit versus x86, which is 32-bit. So here they're saying, why don't we run a exploit suggester script? Now, if you go back here to Meterpreter and you type in the word run, and then you do tab, 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 okay, I do tab 3 times, it'll ask, do you want to display all the possibilities that you have here for scripts? We'll say why. And in this case here, it's showing all the different scripts that you can actually use in Meterpreter. Some really cool stuff, right? You can enumerate if they're using VMware, you can enumerate some shares, you can make your own, right? Check VM, we'll check for some common signatures for for if it's a virtual machine. So all kinds of different things. As you go down through, you can see, right, you just hit your space button and it just keeps going down and down and down and down, right? So there's all kinds of cool things that you can do by going through all of these. And when it says post, it means that we have exploited the machine. In other words, we have a Meterpreter shell, and we're doing some post exploitation. So what they're suggesting in here that we try is the post multi-recon local exploit suggester. So we're going to run that script there, and it's going to go ahead and give us suggestions based off of the sysinfo of the machine we've broken into. And it's going to give us some ideas of some exploits we possibly could run that may work. And it's just a quick way to not have to do a ton of research into how many they have, but it's always a good idea to research what is it that the exploit is actually doing, right? And you can look under the scripts categories in the actual root of the folder that has Metasploit to be able to determine which one that is. Now, interestingly, it's collecting local exploits for x86 Windows. We're using 64-bit. Now, that's something to remember because later I'm going to go ahead and talk about something called targets, which will not work. It will error out, and it has to do with this right here, where it's actually looking for payloads and exploits that are specifically x86. If you had a machine that was 64-bit and you wanted to actually drop a payload on it, kind of geared toward it, you actually have to get into the payload category of x64, because by default, they're all 32-bit that they're using for payloads and exploits in this case. All right, so we see here that these appear to be vulnerable to all of these different ones. So the one we're going to try is this one right here, is bypass UAC event viewer. Now, UAC would be our user access control in Windows that came out with Windows Vista, and it kind of stops things from running unless you're, elevate yourself to admin privileges, things of that nature. So it was put in as of Windows Vista, and it's still there. So to actually run these exploits, you can't do it inside Meterpreter. So what we have to do is we have to background our Meterpreter session, which we'll do right here by typing in the word background. And you'll notice when we do that, it says background in session 1. Okay, so that's important to note. So if I do a sessions tac L, it'll tell me what sessions I actually have backgrounded. In this case, I can see I have my Meterpreter 1, and here it gives me an ID number. We need to remember that ID number. So now we're back at the MSF prompt, meaning we can actually run these exploits now. So now we know the actual name of it. So let's type in the word use and then the exploit. And then it'll drop us in there. And again, it's going to default to Windows Meterpreter reverse TCP. Now notice it doesn't say x64 Windows Meterpreter reverse TCP. That is a different payload for 64-bit. And I'll explain a little bit more of that in just a second. So when I say show options, it's going to show me some different options for it. Now this one actually may have some more information. Let me do this real quick. Info. Okay, so this one's a little bit more verbose. Here it's saying that somebody right here, these guys, contributed this, and it's for the platform of Windows. Privilege, no, because we're trying to bypass UAC to give us privilege. We're essentially trying to get privilege escalation here from the regular dark user that we have broken in as. When it says rank is excellent, that means it's highly likely it's going to work. There are some that are pretty buggy that may not work. Now, this is what I'm talking about here. So it defaults to x86. Now, we do know from sysinfo that the machine itself is 64-bit. So you would be tempted to set target to 1, okay? If you did set target to 1 and try to run the exploit using the default payload that they have, it's not going to work. It's going to error out because the payload itself is not 64-bit. It doesn't match. So if you do run that, just kind of exploring on your own, saying, well, what if I did this set target for this? I'm just telling you that's what's going to happen. So we're going to skip doing that. But I'm just pointing that out, that you can actually specify the target if you do know what the target architecture is. So here it gives us a description here. It'll bypass Windows UAC by hijacking a special key in the registry under the current user Hive and inserting a custom command that will get invoked when the Windows Event Viewer is launched. So it's going to trigger that exploit by doing the launch of the Event Viewer in this case here, and spawns a second shell. And in other words, we'll get another Meterpreter shell that will be more privileged than the one that we have backgrounded, okay? That's kind of the intent of it. It's always good to know what you are doing before you do it as far as the exploits go, okay? So let's go ahead and do our show options again and see what we need. All right, so we do have a requirement to set our session. We do know our session ID is number 1. So we're going to say set session 1, okay? Now, in this particular case, we do know that this is our ETH0 for localhost, and we don't want that. We actually need our ton 0. So we're going to grab that. Whoops, I typed the wrong thing there. We're going to go ahead and copy this and set our localhost for that. So let's go back here. All right, so we'll say set lhost like that. Okay. Now, if we do our show options again, we can see that there it's set there. That's set there. We're not going to set target, but if you did want to do it, it would be set target 1 for 64-bit. But I'm telling you it won't work because, again, the actual payload, this one here, is not the 64-bit version of that payload. Now, there is a 64-bit version, and I believe you have to preface it with x64/Windows, if I'm not mistaken. Or maybe it goes here, x64 there. I can't remember. But anyway, now that we have all the information we need, let's go ahead and see if we can actually run it. Now, a lot of times these bypass UACs don't work the first, second, third, 8th time. So sometimes you have to be patient and run them again and again and again. In this case, it looks like it's working for us. Yep. Awesome. So it says Meterpreter session number 2 has now been opened. So now if we do our sessions, I don't know if we can, no, we can't do sessions in Meterpreter. So if we were to background this and do a sessions tac L, it should show 2 now. And we'll look at that when we're done with this whole process. All right, so now we have got our second Meterpreter. We should actually have some more admin level privileges. So let's type in get privs. Okay, so yeah, we got quite a few things here, right? We got some backup privileges. We got some impersonate privileges. This is a good one right here. Take ownership privilege. We're actually going to go ahead and migrate to a different process to run something they call Mimikatz. So yeah, pretty awesome stuff. So the intention of this challenge is they want you to get the username. I'm sorry, they want you to get the password for Dark, the guy that's the user here. So to do that, they want you to run this Mimikatz thing right here. Mimikatz is pretty well known, and I will say in the real world, if you try to just load Mimikatz, most antiviruses will flag it. Now, there are some different versions of it that are a little bit more, that are encrypted and obfuscated. Something like Mimikittens is one. There's quite a few different ways you can kind of obfuscate it so it doesn't look like the same exact one. And there's some certain keywords you can kind of manipulate to make the antivirus or EDR solution not pick it up. But in the real world, it's almost guaranteed it will pick up Mimikatz. But again, if they're not using any type of good EDR antivirus, then you're good to go. In this case, Meterpreter actually has a module you can load called Kiwi that is Meterpreter. That is Mimikatz. So let's go ahead and load that module. So we'll say load Kiwi. Now you remember the help file before, the first thing it started off with was, I think, timestamp and then hash dump, right? Under the help file. So if we load Kiwi and we do our help now, you'll see there's a totally new section now underneath the timestamp one we saw before called Kiwi commands. And this will tell you kind of what you can do, right? You can create a golden ticket to kind of abuse Kerberos. And some of these will require that you're using, that you're actually a different user, like NT authority, right? So like this one here requires system. In this case, I think we're going to have to get system access to run creds all to actually get all of those credentials. So NT authority system is kind of like the God mode, I guess you could say, that we're looking for. They separate in Windows different things by ring levels. And in this case here, just think of system being God mode. It's called NT local authority / local system. So what we do is we do a PS. It's to list all the processes that are running on the victim machine. And you can see right here, there's one, right? There's one. So there's all kinds of different ones that are listed here. Now we do have the ability, due to the get privs command that we saw, to actually impersonate tokens and impersonate and take ownership and things of those nature. So what we want to do is we actually want to migrate to a instance or a process that has NT authority system. That way we do have those privileges. Now in the TryHackMe, in this challenge, they suggest the print spooler, I think. Yeah, right here. The printer spool service happens to meet our needs specifically or perfectly because we want to live in the process that has the same architecture as the LSASS service, which is abused by Mimikatz to get the credentials. So in this case here, that's what they're suggesting. So that would be this one right here, spool SV. And we can see it is indeed NT authority system, okay? And we can see it's under the system 32. And over here, the far number to the left is going to be our PID number, process ID number that we're going to use. And we're going to migrate to 1264, or attempt to. And if we can do it successfully, it's going to put us into that and spawn a new process under that with those authority permissions. So we're going to type in the word migrate, and then I already forgot the number. 1264 is the number for the spooler. So we'll hit migrate and we'll see what happens. So we're migrating from our current process, which apparently is 3800, to one that, okay, there we go. So now if we do our get UID, before it was dark PC / dark, now, bing, pop, 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 another server drop. We are now NT authority system, which is pretty awesome. So now we should be able to run our Mimikatz creds all, if you remember from the Kiwi commands. So let's go ahead and see if we can get all the goodness here. Get the password for Mr. Dark. Look at that. Pop, pop, pop. Another server drop, and we see Dark PC. We see the username, and the password is password 01. Pretty cool stuff. And you can see it found the actual LM and NTLM hash. And this is typically what they'll probably crack, is this particular one here. And I think I remember from back in my day of teaching these different classes. I was a Microsoft instructor for a while. And there was a particular string that would indicate whether this was LAN manager was still active on that machine or not. And I don't remember what it was. But anyways, they're typically, from Windows 7 on up, are going to be using NTLM or NTLM version 2 for it. And that's more than likely what Mimikatz had cracked or used to crack in this case here. All right, so there we go. We have now completed the challenge. Now, they also go in later here in this challenge down further under post-exploitation. It starts saying some of the things that I had already mentioned in there, like doing a hash dump. They said in this one here, it won't crack administrative password. They made it intentionally difficult, so there won't be any password spraying on this particular VM. But you can do all kinds of different things like record mic, and these are things we went over earlier. And then you could also use Mimikatz to make a golden ticket. And we knew they used 3389, right? They had port 3389 open, and that right there is going to be considered an RDP port. Now, one of those registered ports in that case there. So here is a script that you can run, and that will enable RDP on the victim if it's not already enabled. So we can go ahead and see if it's enabled by copying and pasting. So let's see if it actually is enabled. If not, hopefully it will enable it. All right, RDP is already enabled. So we now know that we can RDP into it, and we do have the password if needed. To do that, you can run another script called run VNC. Boom, that's that. And this, hopefully, will give us a VNC GUI. There we go, look at that. Ooh, pop, pop, pop. So right there, we can actually visually see the victim that we have broken into, and we have access now to control it. Now, do keep in mind, it will probably kick out anybody that's in there and let them know that you're here. So you may not want to do that, but it's there if you did want to tackle that. So pretty cool stuff. So let's close out of that real quick. So one thing I did want to show before we wrap up here is I want to background this. So if I do sessions TAC L, we should see two different prompts. Now you'll notice here we have our first one that we had, our initial one that we popped into, and then the next one that came up was this one. Interestingly though, it did actually put in that x64 Windows payload when we did the bypass UAC. So that's kind of cool how it auto-picked that, I guess. And here we can see that's who we've logged in. Here we can see the actual address of the source and the one that we're actually connected to here, right? So in this case here, this is the Meterpreter prompts. If we wanted to go back into this one, we have to just note the number 2, right? And then we say sessions TAC I, and then the number. So I'll say 2. And that'll pop me right back into that particular Meterpreter, right? So if we did our get UID, we can see it is NT Authority System. Pretty cool stuff. So anyways, learned quite a few different things on today's video as far as Metasploit goes and Meterpreter. So if you weren't familiar with Meterpreter or Metasploit to begin with, this was a good class for you here to learn this sort of goodness. So always remember, just verify and understand exactly what you're doing in these different pop sessions, if you will, so that you're not just copying and pasting what I tell you to copy and paste, but just kind of explore a little bit and do some different switches and try some different things, but understand what you're looking at by doing info on these different exploits so that you don't actually, blast it yourself without causing real issues. Now, another thing you can do as well is you can go to a site called ExploitDB, and you can actually look for the exact same exploit in this one by doing CVE 2004 what was it? Shoot, I can't remember now. Oh, it's right there, 1561. 1561, and do a search for that, and you can see right there is the exact same one. Okay, and you can see that's the Metasploit one, and you can actually read the Metasploit module portion of it itself. Okay, now what you can also do is come back here, and you can also try one of these other ones, right? This is still the same Icecast, so I can go to this and I can research the exploit itself here under this one, and I can try to run it. So this one here is using a C language exploit, and it's going to be including all the shell code and stuff like that. So if you're into that sort of thing and you want to actually learn a little bit more about exploitation outside of Metasploit, this is one way that you can do it. Now it is handy to learn this, especially if you're doing something like an OSCP, Offensive Security Certified Professional exam, because on the OSCP, which in my opinion is probably the best certification for penetration test and red team and that sort of thing, But on that exam, they give you 24 hours to blast into as many boxes as you can. I think there's like 5 of them. And their rules are you can only use Metasploit module, exploit module for 1. So there was a gimme one in there for, I think it was a Windows XP or something when I had originally seen that. And it was, you can blast the MS-067 or whatever it was called and use that, your one gimme on that. Now, you can use Metasploit for things like the auxiliaries and the scanning and things like that. And I think you can also use it for post-exploitation on those exams. But in general, they only let you use it for exploitation once. So it's always good to know how to do the exact same exploit that was in Metasploit by doing it manually this way through ExploitDB and understanding exactly what you're doing on this one. This, like I said, it would be a little bit more difficult than the Metasploit one because that one's more of a copy and paste and type by number type of deal. But it's always good to kind of learn that as well. So I would recommend exploring the different ways that you can exploit the exact same thing in Metasploit and in this one as well. So yeah, awesome stuff we learned today. Metasploit, Meterpreter, all kinds of cool stuff. We'll see some more of these as we go down through our Pop series. Do be aware that on my YouTube channel, I also have another series called Bounty Hunter Training, and that's going to be focused on web application security, where I go into some stuff to teach you about bug bounty hunting, where you can learn some techniques from OWASP, common categories, and things of that nature. So that's a good one for you to get into if you want to look at that. And as always, subscribe and click the notification bell on my YouTube channel here to get more videos like this on the series. So, till next time, keep on popping, y'all. Peace out, players.